So one roller is resting on the horizontal surface, okay, and here the weight of this roller is W, and it is connected with one pulley, okay. This is one pulley, this is the other pulley with the string. This side we are keeping one load P, and here with the vertical side pulley we are connecting another load Q it is. Now this string AC string is making alpha angle with the horizontal, okay. This is parallel to this horizontal. Now here how many forces are acting at A point? This Q force in the string, this P force in the string, 2 forces, weight is acting in downward, 3 forces, and here this is a contact point. Because of the contact point, reaction is acting upward, okay, on the sphere. So there are 4 forces are acting. We can't apply Lami's theorem. Lami's theorem is only for 3 forces. Just do the resolution of forces here. Now I am taking A point. A is the center. Now W is acting downward, weight, okay. Q is acting with alpha angle. Q is in upward direction I took, and the reaction at this point is in upward direction. It is perpendicular to the horizontal surface like this, and then P force is acting like this. It is horizontal. Here take this inclined component in as horizontal component and vertical component, okay. For this horizontal component already I told, for horizontal cos is coming Q cos alpha in this direction, vertical is Q sin alpha in this direction. Just divide the forces or resolve the forces. Redraw the diagram at A point. W, this is the P, R is vertical. Here horizontal component is Q cos alpha, vertical component is Q sin alpha. Now for concurrent forces, because all forces are acting at A point, so we can call it as concurrent force system. For equilibrium of A point, we are applying sigma Fh is 0 and sigma F is 0. Unbalanced horizontal forces sum should be 0, and similarly unbalanced sum of all vertical forces should be 0. First take this condition, sigma Fh is 0. Take this one, sigma Fh is 0. In this direction I am taking positive, okay. In this direction forces I am taking negative. Now what is the first horizontal force? Q cos alpha, in this direction positive. Next force is P. In this direction it is negative. Write down Q cos alpha minus P is equal to 0. From this we can write P is equal to Q cos alpha. It will come this side, okay. Minus will gone. So similar, here we have to find the angle cos alpha is equal to P by Q, or alpha is equal to cos inverse of P by Q. Here we have to find this angle, okay. So that angle is equal to alpha is equal to cos inverse of P by Q, and similarly apply the next condition, sigma F is 0. Now here in sigma F is 0, upward force is positive, downward force is negative. What are the upward forces vertically? R and Q sin alpha. Downward forces are W. So here write down R plus Q sin alpha, R plus Q sin alpha minus W, downward it is minus. So from this R is equal to, we can write W, this side will go positive, minus Q sin alpha is equal to W minus Q into sin alpha. We can write root of 1 minus cos square alpha, because sin square alpha plus cos square alpha is 1. So we don't know sin value. Sin square alpha is equal to 1 minus cos square alpha. Sin alpha means root of 1 minus cos square alpha. Why we are writing this means we know cos alpha, P by Q, okay. So in it we can write R is equal to W minus Q into sin alpha means root of 1 minus cos alpha means P by Q, P square by Q square. So at the end Q, if Q is coming out, so in the bracket it is, in the root it is Q square minus P square by Q. Here it will come, the outside is also 1Q, Q will be cancelled. The final R is equal to W minus, like this, Q will be cancelled, W minus root of Q square minus P square. So this is the reaction we have to find at this point for the roller, okay. So we have to find R value and alpha value. This is the solution. Alpha is cos inverse P by Q and R is W minus this entire term. If you like this lecture, please subscribe my channel, share with your friends. Thank you for watching.